something like that, right? Okay? Well, if we were a true surveyor or civil engineer, we wouldn't have chosen point A at the 0, 0. I chose 0, 0 because I wanted us to have negative values so that you could see west if we had it, but we didn't have any west, but we did have some souths, right? So in the end, instead, you pick a coordinate of like 10,000, 10,000, and this is point A. So when you draw your picture now, whatever, you actually are, all values are in the positive, okay? And typically when we go out in the field, we do just pick an arbitrary number. We pick an arbitrary coordinate, because we want to just get moving and just do surveying. You don't want to like fool around out in the field to try to find out where the stake coordinate is. You just say, I'm doing 5,000, 5,000, you go out there, you do all the surveying, and when you come back in the office, then you look at the stake coordinate system, and then you overlay your drawing. Those of you who have AutoCAD skills or some kind of drafting skills, on the computer, once you draw something, you can move it wherever you want, right? So you could draw it at 10,000, 10,000, and then you could say, oh, it's really a stake coordinate of 2,500, 100, and you just move the whole picture down to another coordinate. Or you can move the origin to another point, right? Okay. So let's look at the next step now. So the next step, and I'm skipping a page, is how to calculate the error. It's very similar to what you did in leveling. So I'm on page 37. So what are these numbers? These are the numbers that we got for the coordinates, right? So, sorry, this is the latitudes and the departures. Did everybody hear that? It's not coordinates, it's the latitudes and the departures. So going from, look at the first column. The first column represents lines. So going from A to B, I had a northing of 334.91 and I had an easting of 457.94. And then going from B to C, I had a southing. There's no such thing as southing. It's a northing of a negative 505.48 and then a 633.89. So these are the departures and latitudes that we calculated. And if you add up all the north latitudes and all the south, shouldn't this number be the same? If we came back to 0?
Yes.
But they're not. There's a difference in latitude. And of course, it's the 0.06 that we found we had an error. And then for departure, we add up all the eastings and then we add the west, and these numbers should be the same, but they're off by 0.03 because that's our error in departure. So you see this capital E here? The capital E means error, and L is latitude and D is departure. I do say error with the New York accent, don't I?
Error.
Oh, it's glaring.
Yeah.
Why do they say departure instead of longitude?
What?
Why do you use departure instead of longitude?
Just
Because
like
it's not longitude.
Okay.
Longitude is spherical.
Oh, right.
Right? If you have a globe, we have a globe somewhere.
It's
over there.
Oh, there it is, and that's latitude and longitude. We're talking about the plane.
You know,
Okay.
tangent plane here.
Say error.
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 Sarah loves to impersonate you.
Oh, really?
Yeah.
There are 3 words that I haven't been able. Error, draw,
Yeah, I was gonna say drawer. I definitely can't say drawer.
yeah,
Draw.
and then
Can't
Arthur.
say.
Arthur, like my husband's dad's middle name is Arthur. And we were thinking about naming the kid Arthur. I was like, there's no way in hell I'm going to pull that off. Well, coffee. I can correct myself.
Randy?
Cool.
Okay, so let's figure out, okay, I want you to figure this out. How is the correction in latitude from A to B? This looks very similar to what you did in leveling. You took the distance from A to B over the total distance, and you multiplied it by the error in latitude. And you got 0.0103, which we round to 2 decimal places because we're only using 2 decimal places. Can you tell me what the difference is between this correction and what you did in leveling? There's a difference.
Looks like you're taking the distance from one point
With the net, it doesn't accumulate.
Doesn't accumulate. Right, in leveling, the numerator the numerator was always accumulating. It was a cumulative value. But here you're not, they're all isolated, they're acting independent. So we get a correction in latitude from A to B to 0.01, correction latitude B to C, 0.1, C to D, 0.2, D to E, 0.1, and E to A, 1, and if you add these up, 1, 2, 4, 5, 6, they come out to be 0.06. So now look at the top of the sheet and the next sheet. Kind of keep flipping back and forth. So let's look at the correction. So look up here for a minute. So for the latitude and northing for AB is 334.91, right? We calculated that the correction is 0.01. Are these numbers too big or are they too small in comparison to the south? You add up the norths, you add up the souths, which number is bigger here? North. The north is bigger. So that means these numbers are too big. Let me say it again. You add up the three northings and you get 1195.14. You add up the two southings and you get 1195.08. The northings are too big. So if you had 334.91 and the correction is 0.01, what are you going to do to this 334? Subtract it. So what should you get? 334.90. Okay?
I don't understand why, I understand that, but I don't understand why we had to determine which one was bigger.
Because that's the one we're taking care of.
But in your,
Oh,
because in your chart, you took 0.01 off.
Because the reason why is I'm doing a correction, but this is really, I guess what I should do, this is probably a better mathematical relationship here. This is an absolute value. You're calculating the correction in latitude, but there's no sign attached to this.
Okay.
So all these are absolute values. So you have to decide, is it a positive or a negative error? Okay? Does that make sense?
And you just do that by which number's bigger.
Yes, that's right. So let's go back now. So if we look on here, we notice that the north, the positive ones are too big and the souths are too small. Right, just looking at absolute value. So the correction from A to B was 0.01, so I subtract it from this and I get 334.90. So let's look at DE. The correction for DE was 0.0012. So what do I do here? Subtract it. So the answer is good. The corrected value is going to be 309.96. 309.96. How about E to A? Again, it's a 0.01. Again, it's still in the northing. It's too big, so it's subtract 0.01. It's 550.25. Now when I add them up, they're 1195.11. But let's do the others. Going from B to C, I have 505.48, and we already said that these numbers are too small. So the correction for BC is 0.01. What should I do with this 48? Add a 0.01 and it becomes 49. And then the next one is a 0.02. So I take the 689.60 and I add 0.02 and you get 689.92. And now when you add up the northing and the southing, you get the same number and you just distributed the error fine. It's a lot of calculations. It's not hard math, but it's a lot of calculations. And you're gonna get the practice and homework. You're gonna do a problem exactly like this.
Only one. I'm just kidding.
It'll take a while.
I know.
Okay, so now let's do the correction for the departure. Look, I didn't write the equation, right? Why? What do you think? What is the equation? Let's see. So what's this equation here? We're doing the correction and departure for line AB. So it would be what? The error in departure times the distance AB over the total distance. So the distance of AB is 567.34, and I divided by the total distance, which is 3,300, and that gave me, when you rounded it, you get a zero correction there. And then let's just do one down here where there's more room. So this would be the error in departure times
Line
DE divided by the total. So which ones do we apply a correction to? B, C, and CD, right? So, go up here. So B, C, and CD are the ones, right? Well, when we look at these numbers, we have a number that's too big or too small? Too big. How about this one? Too small. So the 633.89, and I found a correction of 01. So what do I do to this number? 633.89, I subtract 01, and it comes out to be 633.88. And then what about this one? These numbers are too small, so 613.12, what do I do with the 0.01? I add it, so now it's 13. But only 2 got corrected, right? And remember, we had an error of 0.03, so it's just kind of rounding error. When I add up the easting and the west, there's still a hundredth of an error, but it's, you know, if you already distributed it, it's fine. Okay, let's go up. Let's go back to the question. So, complete the interior angle, no problem. Bearings, no problem. We did all the coordinates with that closure error, and we determined the latitude and departures and the errors and adjusted the latitude and departure. The last thing we're doing is the coolest. Coolest. Okay, when you want to calculate, so they want you to find the area, right? So just with, you know, the math that you've had, you know, math that you know already, how would you calculate the area of this traverse?
Integrated.
Okay, that's one choice. We need a line, we need an equation of a line, right? Okay, so you've done integration already to get area, but you need an equation of a line, and I don't think we're going to be able, that's
Piecewise.
5 lines. Okay, what else would you do? Let's go back before you did calculus.
Geometry.
Make it into triangles.
Right, break it up into triangles and squares and rectangles and figure it out,
Are you getting any questions?
okay? There is another way to do area. Remember in your taping? Do you remember your taping? There was that equation, S times
Right.
S minus A times S minus B times S minus C. Did you ever write that on your cheat sheet?
Yeah.
No.
Okay, write it on your cheat sheet.